Hi, this is Nathan Tintle. In this Learning Goal video, we're going to talk about how to use the one proportion applet to conduct a simulation. We're going to use the Condolphins Communicate example to talk about this learning goal. If we want to simulate what would happen if Buzz was just guessing, we need to know three things. We need to know what's the probability of getting heads in this coin flipping chance model. In other words, what's the probability of a success, that's a correct lever push, if Buzz is just guessing. We need to know the number of tosses of this coin. That question is, what's the sample size? How many times did Dr. Bastian do this experiment with Doris and Buzz? And we also need to know the number of repetitions. How many times are we going to repeat this study, assuming Buzz was just guessing? That is, how many times are we going to repeat using our chance model to get a sense of the kinds of outcomes that are typical or atypical? Let's go to the one proportion applet. First box we need to enter is what is the probability of heads. In this case, the probability is 0.5. This represents the likelihood that Buzz pushes the correct lever if he's just guessing. In this case, we enter the number 16 for the number of tosses because Doris and Buzz have looked at the light and tried to push the correct lever 16 times. Even though ultimately we want to do lots of repetition, we're going to start by doing a single repetition. This will give us one set of 16 coin flips. So we can see now one coin being tossed 16 times. Sometimes heads, sometimes tails is what comes up. We get 9 heads, 7 tails, 1 dot on the dot plot. As we continue to push the toss coins button, and I'm going to take animation off, we're going to continue to flip 16 coins. This time we got 10 heads, and the dot goes on the dot plot at 10. 7 heads, 8 heads, and so on. Each dot on the dot plot represents the number of heads when we flip a coin 16 times. We're beginning to get a sense of the kinds of things that are likely and unlikely to happen when we flip a coin 16 times. I'm going to increase the number of repetitions now so that the total number of repetitions is 1,000. I now have 1,000 dots on this dot plot. I'm getting a sense now of the numbers that are likely, let's say between 4 and 12, and unlikely outside of that range when we flip a coin 16 times. Notice that this distribution of dots is centered at 8. In other words, a typical value, or the average value when we flip a coin 16 times, is 8. This makes sense because 8 is half of 16, and the probability of getting heads is 0.5. Finally, what do we really want to use a dot plot for? Well, we have a sense of values that are typical and atypical. What we're really curious about is, where is our result from this study? Well, in this study, Buzz actually got 15 out of 16 correct pushes. Out of all 1,000 repetitions of this simulation, not once did we get as many as 15 heads, meaning it's highly unlikely that Buzz would push the correct lever 15 out of 16 times if he was in fact just guessing. A few words of caution. For right now, we've shown you how to use the applet with a probability of heads equal to 0.5. Later in the book, we'll look at different values. Make sure that the value you use matches the simulation you're trying to conduct. In this case, we want to know what happens when Buzz is just guessing. If he's just guessing, he has a 50% chance of pushing the correct lever. Another word of caution when using the applet. I often see it that students mix up the number of tosses and the number of repetitions. The number of tosses is equal to the sample size. We're flipping the coin 16 times. We're then repeating that many times. So the number of repetitions will always be a number like 1,000, or if you want more, you can even do more, 5,000 or 10,000. Finally, keep in mind the goal of the simulation. We're asking about how surprising our observed result is, that's Buzz pushing the correct lever 15 out of 16 times, if in fact he's just guessing, that is, if the chance model is true.